hello there, lovely one. It's me, Helen the Great, and we're going to plot this function over here. Now, whenever we plot a function, the first thing we need to look at is the shape. We need to determine what kind of shape it is, and then we find the intercepts. Now, sometimes this is enough information to plot the function, and sometimes it isn't. But with most of them, it is. So what is the shape of this particular function? In order to determine the shape, we need to look at what is happening to x. In this case, x is being squared. Squared, as you know, a square shape is a quadrilateral. So what kind of function is it? It's a quadratic function. Now we know a quadratic function either looks like it's smiling or it looks like it's frowning. And we know that we can determine whether it's smiling or frowning by the coefficient of x squared. In this case, the coefficient of x squared, otherwise known as the value of a, is more than 0, which means our shape is going to be smiling. You'll notice I didn't do any calculations to determine the shape. I just looked at what was happening, and then I was able to determine it. You need to know your functions well enough to be able to do that. Now, in this case, we are going to look for our y-intercepts, well, this case and every single other case, and we're going to look for our x-intercepts. In order to find the y-intercept, we've got to make x equal to 0, and in order to find the x-intercept, we've got to make y equal to 0. There are two different calculations, so let's just draw a line across. If x is equals to 0, we need to substitute 0 in for x, which means y is going to be negative 16. Did we need to show our calculations? Not really. We could have just said the y-intercept is 0 and negative 16. As soon as I've found out the y-intercept, I'm going to mark it over here. It's quite important that you state the value, because many times you're not actually marked on what's happening in the calculations. You're marked on what is plotted on your graph. It doesn't need to be to scale. You don't need to measure out 1, 2, 3, 4, 5. But it does need to be in ratio. So negative 16 needs to be as low down as you can get it, because it's actually quite far from 0. And look, I've labeled my y-axis, and I've labeled my x-axis, and I put arrows at the end of each axis. But now let's go back and we'll find our x-intercept by making y equal to 0. And that means I've got 0 is equals to x squared minus 16. It is possible to find the x-intercepts by moving 16 over and finding the square root of 16, but just remember, there are two answers. There's negative 4 and positive 4. And that's why I recommend you always just factorize it, because that'll tell you immediately that you've got two answers. It's obviously a difference of two squares, so that means x is either equal to 4 or x is equals to negative 4. Remember, these are coordinates, so write them down as coordinates. We've got two of them, 4 and 0, and negative 4 and 0. Now, because 16 is down over there, that means negative 4 will be somewhere over there. Negative 4 and 0. And positive 4 is going to be mirrored on the other side, so it's going to be 4 and 0. I know what the shape is going to look like, so I'm going to draw it now. I find it easier to draw from the center and then either draw up or draw down accordingly. I just find it gives a nicer shape. Now, in terms of where your marks are, you're going to get a mark for your x-intercepts. It might be 2 marks for each one, but it might only be 1 altogether for both of the coordinates. You also get a mark for your y-intercept, and you'll get a mark for your shape. Now, if your teacher wants to give you any other marks, it's going to be, have you labeled your axes? And what is the level of neatness? If I were marking this, I would give it 4 marks out of 4. Well, that's it for this question. Much love.